person is standing on the roof of a building. The person tosses the ball into the air so that it will land on the ground, not on the roof. The situation can be represented by h of t equals negative 16t squared plus 40t plus 20, where h of t is the height in feet and t is the time in seconds. And then here they want you to determine the height of the person on the roof above the ground to the nearest whole number. So what am I literally just asking for? Nope. Nope. If I was getting... Okay, let's think about it. You guys just made him jump off the roof by saying vertex. So he's here, and then what does he do? He throws the ball, not himself. He throws the ball into the air, and then the ball lands on the ground. We agree? So where is he standing? He's standing here. So what am I asking for? The y-intercept. I'm asking for time 0 before he even releases the ball. I'm asking for when t equals 0 seconds. So it's just the y-intercept, which I could go to my calculator and find. Or, in an equation, which of these without brackets is the y-intercept? The 20. So it's 20 feet. And then it says, determine the height of the person on the roof to the nearest whole number. The height of the person on the roof is 20 meters. Not meters. Feet. I don't know why I just put meters. Okay. Then it says determine the time it takes for the ball to hit the ground. I'm asking you to find when I say hit the ground. The x-intercept. So we would go to our calculator and we would go second trace number 2. And then I go left bound. Come on. Left bound, right bound. Enter. And you get 2.9 seconds. So, it takes, Colton, 2.9 seconds for the ball to hit the ground. So I can ask for the y-intercept in a certain way. I can ask for the x-intercept in a certain way. I can ask for the maximum. The catch with the maximum, though, is it gives you two things, right? It gives you an x and a y. It gives you time to reach max, and it gives you the maximum height. So here it says determine the maximum height. The moment I see maximum, I just need to find the maximum first, right? So I go to my calculator and I say second trace maximum. And then I need to be left bound of it. Enter, right bound. Enter, and I get 1.25 and 45. So whenever I write it out, I'll put the units with it because it will help me out. So the 1.25 is in what units? Time, which is? And then the 45 is in y, which is height, which is feet. So that should help me out when I'm answering questions. So here it says, determine the maximum height of the ball. Which one do I care about? 45. So we take the maximum height of the ball is 45.0 feet. Then this one says, determine the time to reach maximum. So now what am I asking you for? The time, the 1.25, right? So the max I can ask you for either or. You have to pay attention to figure out which one. So the time, the ball, I guess I should say, reaches maximum. You know, this makes my writing look terrible. Maximum height at 1.3 seconds, because that's the nearest 10. One decimal place. Now here it says, what was the height of the ball at 2 seconds? So t equals 2, and t is in the x position, correct? So when I know x, I go second trace value, 2, enter. And it's 36.0. So the height of the ball at 2 seconds is 36.0 feet. Then what time was the ball at a height of 15 feet? So watch yourself. This one says what time was it at 15 feet? So 15 feet is my y2, because it's my y. Now why is there only one time and not 2 times? Make sure your phones are away because you're not learning if your phone's out. Why is there only one time and not 2? Because you don't want negative time. This thing starts at 20, like right here is 20, right? So negative 15 would be like somewhere over here, and that's negative time, which makes no sense. So there's only one of these that makes sense. So I go second trace 5. I need to be near the intersection. Now, if you don't know where your cursor is, I used to just hold it and hope for the best in high school. Not a good thing. Right here, it tells you where it is. So it says it's at 5.8 and negative 2.91. So it's like somewhere down here, right? So I need to cursor left to see it, to get it back on the screen. Now I'm at 5, now I'm at negative 180. I'm getting closer to the x-axis. Negative 3, negative, oh, now, there we go. So now I am closer to it. So I go enter, enter, enter. And I get 2.61 and 15. So that's the nearest tenth, so 2.6. So the ball was at a height of 15 feet at 2.6 seconds. Now this one says determine the times the ball was at 21 feet. So it's 15, there was only one time. With 21, there's 2. Why is that? Where does this graph start at? Where is the guy standing? Standing at 21. So it does cross here in the positive. I changed it to the nearest hundredth. You guys have to the nearest tenth. The nearest tenth doesn't make sense with the one answer, so I changed it to the nearest hundredth. But we go second, trace 5. We need to be near one of them. I don't know why it really wants to keep starting negative. Actually, I'm going to pop up once that way. So enter, enter, enter. And I get 0.03 seconds. So right away, which makes sense, it happens in 2.9 seconds, right? So it's going to reach 21 really fast. And then second trace 5, we have to move close to the other one now. Now you can ride the curve, which takes longer, or you can pop down onto this one and ride it over. But you need to move it close to the other one. If you just hit enter, 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 you're going to keep finding the exact same one. You can move it before you do it. So it's 2.47. So I would write a sentence that says the ball reaches a height of 21 feet at both 0.03 seconds and 2.47 seconds, right? Now we need appropriate domain and range. When it's a word problem, we end up having that sandwich domain and range. So we have a graph that looks like this. This is the only part that matters. And the reason why is this is negative time and this is negative height. Can we have either of those? Negative height would mean you threw the ball so hard it actually went through the ground into like magma or something. I don't even know what's in the center of the earth, which you are not that strong. Neither is this person. This is negative time. You're not a time traveler. So that doesn't make any sense. So what is the lowest time I can have? 0. And then when did this one happen? When did it hit the ground? at 2.9, correct? I think it was 2.9. So that is the only x's I can have. After that, it's entering the ground, and before that, it's negative time, so it doesn't make any sense, correct? So I can't use x because this is not, there's no x in this equation. Let's look up here. What is the x in this equation? What variable is it? T. So we have to use t when we use the domain. So make sure on your test you use t, if t is the new x. So we're going to go t such that, and then we go low to high. So my lower number is 0, my highest number is 2.9. So I list my 0 first, my 2.9 last. I throw my t in the middle. And then I use the slanted L's, right? Both less than symbols. If you do this every single time, it'll work, but you have to go low to high. So it's less than or equal to, less than or equal to, and then t is an element of the reals. And now you're saying that t is sandwiched between 0 and 2.9. But you have to do the slanted L's, right? They have to be less than signs. What is my variable for y? H of t. So I'm going to have to go h of t as my y, like this. Now what the heck is my lowest y in feet? 0. It can hit the ground. And what was the highest y in feet? 45. It was that maximum, right? And then all the y values between 45 and 0, I can find a value for it because the graph continuously goes through them, right? And some of them I can even find 2 times where they hit that. So we go low to high. So we go 0, we go 45. We put the h of t in the middle. And then we go less than or equal to, less than or equal to. H of t is an element of the reals. Okay, you're sandwiching it between 2 values. Then we're going to talk about the graphs. What type of graph is A? Linear. That's one thing about it. Which means it's in the form y equals ax plus b. This particular graph, what can you tell me about b? B is positive, and in particular, it's actually 5. Because it specifically gives me a value, right? You could say b is greater than 0, you wouldn't have been wrong, but it actually is 5 too, right? That's a true statement. Now your A tells you how it ends on the what? Your leading coefficient tells you how it ends on the right. This one ends down, so my A is negative. Ends negative, so my A is negative. What degree is this graph? What is my y-intercept? 0 and 5. It is a coordinate. Always has to be. What is the number of x-intercepts on this one? What are the possible number of x-intercepts on a linear? Minimum is 1, because the disk goes. Maximum is 1, because the degree is 1, right? No matter what, it's going to have to go through 1. How many turning points does this graph have? 0. What is the turning point? Max or min. So this one has no turning points, or 0 turning points. That's the same thing. What's my domain and range of a linear? Because it goes up and down for life and out and right and left for life. XER, YER, make sure you have the squiggly brackets because that means a set of values. Say D equals or domain equals. X such that X and L are the reals. You have to say that it is the domain somehow. You can't just write X, XER, Y, YER and not tell them it's the domain and range. Because some people actually don't know that the X is the domain. And my range would be Y such that. Y is an element of the reals, yeah. What type of graph is B? It's a quadratic. It's a grade 11. Linear was grade 10. Quadratic is in the form y equals ax squared plus bx plus c. What is my c? My y-intercept is -1. What's my A? Yeah, it's up on the right. So A is going to be positive, so A is greater than 0. If it's open to the variable, it's greater than. And because it's degree 2, it's also up on the left, because they do not disco, right? It's the only ones that don't disco. It's degree what? 2. What is the y-intercept at? 0 and -1 coordinate. Number of x-intercepts? Now, this one has 2 x-intercepts. That is a true statement. What is the possible number of x-intercepts for a quadratic? 2 is one of the options. 0 is the lowest. And you can have 1. If your vertex is actually on the x-axis, you have 1 x-intercept, right? From the cross through. So you can have 0, because it could be completely above or below, and degree 2 are the only ones that can do that out of 1, 2, and 3. And then we have 1 or 2. How many turning points does this one have? So the only equation that has 1 turning point is a quadratic. So the moment they say 1 turning point, you know it's a quadratic. My domain is going to be XER, because the arrows keep going out for life. My range is the only one that isn't YER. Now I know the lowest it can be is -3 or above, right? And above means positive, means what's another word for the inequality sign that this means? Greater than. So it's going to be y such that y is greater than, so it's open to the variable when it says greater than. Greater than, it's also equal to it, because there's a dot down here, right? -3 YER. What about C? Cubic. And in regressions, that's 4, 5, and 6, right? So we get y equals ax cubed plus bx squared plus cx plus d. What can we say about d? And in this case, it is -2. What can we say about my a? It's positive because we care about that. Right. So a is greater than 0. I know it's down on the left because it's cubic and it just goes. Okay. What is my y-intercept? 0 and -2. Number of x-intercepts? So this one has 3 because it maxes out at 3, right? It always equals the number of x-intercepts, the maximum is equal to the degree. For degree 3, what is the minimum number of x-intercepts? What's the minimum number of x-intercepts? 1. It has to cross through at some point, right? It could also have 2. So your minimum is always the lowest, your maximum is always the highest, and you can always have varying levels of whatever makes it in between. How many turning points does this one have? So if it has 2 turning points, we know it's cubic. But what can cubic also have? It can have a point of inflection, which means where it just curves. There's no max or min, which means no. This board. Looks like I'm ready to get an etch a sketch. So if it has 1 turning point, it's for sure quadratic. If it has 2 turning points, it's for sure cubic. If it has no turning points, it could be 3 or 1. And then my domain and range, when it's an odd degree and not a word problem, XER, YER, because the arms go out for like right, left, and up, down. Lagging so bad, so. Once I draw slow, I can even make a squiggly bracket. Okay, I have another sheet that we're going to go through. We're going to practice how to do regressions of exponential and logs. Now, just so you know, on the test tomorrow, it'll only be 4, 5, or 6. If you look at the little box up there, it says 4, 5, 6, 9, 0, C. Those are the only options we're going to be able to do. And today we're looking at 9 and 0. 9 is logarithmic, and 0 is exponential. So you're just typing them in just like normal. But if it says exponential, we're going to pick number 0 instead of 4, 5, or 6. And if it says logarithmic, we're going to pick number 9. That's the only difference. So it looks like this. No, it doesn't. Looks like this one doesn't like me. I'll show you what it looks like. So we're just typing in our values. We're clearing them all out, and we're typing in this person's debt per month. So as it grows. Okay. So number month 1, month 2, month 3, month 4, month 5, 6, 7, 8. And then here we have the debt, and it's growing exponentially, which means it's starting off slowly, and then as it's going along, it's getting higher and higher and higher, which can happen to credit card debt and stuff like that, because usually your debt has an interest rate on it, so it's going to keep increasing if you're not paying it off, and it's going to increase faster, because the more amount of money you have in, the more interest you have to pay. So you have 620, 761.88, 899.90, 1,039.93, then we get to 1,270.63, 1,589.04, and then 1,851.31, and then 2,154.92. Okay, then we go stat, calc, and then it says on here exponential regression. So on the diploma, the only options we're going to have are 4, 5, 6, 9, 0, and C. If you pick anything else, you're going to be in trouble. Tomorrow for your hands, like for your open book, we have 4, 5, and 6. If you're picking anything else, you're wrong. Like there's no ifs, ands, or buts. Okay? So this one I want exponential, which is 0. So here it is. I hit enter. And then I still just store it like normal. Nothing has changed, bars. However you store it in your calculator, because everyone is a little bit different. Then I go to my window. Now my window is month 1. What if it asks, can I go any lower than month 1? Can I go to month 0, I guess, technically? Sure. It's the lowest month you could go to, because after that you've not even gotten any debt, right? We're just starting in month 1 with debt. And then it goes to month 8. So I'm going to go to month 20. I like always go double, even a little more than double, okay? Then the next one says debt. Well, what's the lowest you could pay in debt? 0, right? You can pay no debt. Or the highest is 2,154.92, so I'm doubling it. So I'm going to go 4,500. And now this is an exponential function. Exponential functions look like this because they start off kind of more flat, and then as they go along, they grow faster and faster and faster, so they'll start peaking and getting straighter up, straighter up, straighter up, straighter up. So you start off slow. It's like bacteria. If bacteria doubles, you start off with 2 bacteria, then 4, then 8, then 16, then 32, then 64, then 128, then 256, and it grows really, really fast. So you start off with like 2, and then by week 5, you're at like, what is it, 2, then week 2, you'd be at 4, then 8, week 3, 16, 32, 64, then you get up to 128, then 256, then you're at 576. It keeps going faster, right? Okay, so we are going to, this one specifically asked us to write out the equation. So I just want to show you how you write the equation. So we're going to go back to that same spot. I'm just going to recalculate my equation. So I'm going to stat, calc, and then 0. So this is my equation. It goes y star b hat x. So it always gives you the format of your equation, just like it did for linear, quadratic, and cubic. So it's y equals a star b hat or roof x. Well, you're not going to write it like that, technically. That's just how it shows it as how the calculator would write it out, correct? What does a star mean in your calculator? What do you think? A star. Multiplication. So we're going to get, I hate this board so much. Y equals A times B. I just put my B in brackets. And what does this little roof to the X mean? It's just an exponent. So it's AB to the X. That's literally what that fancy looking ugly thing is. Everyone paying attention so you know? You're going to try and write this out later and you're going to put stars. I do not want to see the top. I want to see this one. Okay? And then it tells you what the A and the B are. So it says A is 522.90. So I'm going to go y equals 522.90. Would I ever type it in like that, rounded? No, you keep the full thing. You just round when you're writing out the equation. And then bracket b is 1.20 to the x. Whenever this b is greater than 1, this graph is growing. If it's between 0 and 1, it's decaying. This one is growing, so it works. But here it says, if the spending continues at this rate, what is the graduate's credit card debt? What will it be after 1 year? So what's it making me look for? 1 year. Remember, this is x. List 1 is x. Go away. List 2 is y. 1 year. Yeah, what's 12? Which one, x or y?
X.
Yeah. It's just asking you to find when x equals 12. So that hasn't changed. It's just a different equation, right? How do we find it when we know x? We go second, trace, value, 12. And it's 4,499.31. And then you'd write a sentence. You'd say, the graduate's credit card debt would be 4,499.31 after 1 year. So that is an exponential regression. We're going to go to example 3, actually. We're going to go to number 3 right away here because it has less to type in. So, and we have a short period of time. So we're going to example 3. I don't know how much less has to type in. Is one less. So why I want to go here is this is still the year number sold in thousands, year number sold in thousands. So this would be my x, my y, my x, my y. So instead of putting the list side by side, they just have them stacked. Do you see that? But this is the thing I want to draw your attention to. Say they gave me 2020. Say they gave me that year, but didn't give me a y. Would I put that in the table? No. What if they gave me a y of like 200, but then didn't give me an x? Would I put that in the table? No. You always just bypass a point if it doesn't have an x and a y, because there's no way you can leave an open blank. It'll throw off your regression completely if you try and put it in. You'll have one list longer than the other. Okay? So if you have an x without a y or y without an x, you just ignore that part. Okay. So everyone's typing this one in. Go. And then we're going to do a logarithmic regression. So clear out your y equals. Clear out your list. And this is just selling games. In these certain years. So once you have your lists, we're not going to pick 0 this time. We're going to pick logarithmic regression. Now everyone has to pay attention. So when we go stat, calc, I know you'll see logistics down here, and you're going to want to pick it because it has the word log in it. It's not. Logarithmic regression is actually log reg. It's number 9. It's up there, 45690C. Those are the only options we have. So you're picking number 9. So it's in this form now. Do you see that? Y equals A plus B ln X. Y equals A plus B ln, it's ln X. That's not a 1, it's ln X. There's a button that is a ln X button on your calculator. So if we have to write out the equation, it gives us the A this time and the B. So we get Y equals negative 33,803.18 plus 4,466.65 ln X. So I just wanted to show this to you because there's just 2 other buttons that we're going to be getting into because we're doing exponentials and logs. Tomorrow your test is 4, 5, and 6. That's your only option.